Okay, so for the first one, we're just going to distribute 3x squared times 5x is 15x to the third, and 3x squared times 2, 6x squared, yes. Over here, we have x times x. X squared, remember we referred to that as the f in FOIL, the first. Then we had x times 7 is positive 7x. We referred to that as the O in FOIL, the outsides. Next was the I in FOIL, which was the insides, 3 times x, 3x. And then L would be the last, which would be 3 times 7, 21. And we're going to combine 7x and 3x. So it's x squared plus 7 and 3 make 10x plus 21. Well, what our purpose is today is we want to reverse that process. Remember we did factoring with something like 6, where we split it into 2 times 3, so 6 is 2 times 3. Or we had even a bigger factor tree. It might have been, 18 splits into 2 times 3 times 3. You keep splitting it down, you can't split them down any further. Same type of thing here, where we're going to reverse that multiplication process. So for this one here, the first method we usually look at is called the GCF method. GCF, of course, stands for greatest common factor. What that means is we look at the digits in the number. Here we have 15x to the third and 6x squared, and we find the greatest common factor of those digits. Now, if you remember how we did that, we look at the numbers first. 15 and 6. What is the largest number that goes into both of those? Goes into both at the same time. Yeah, it'd be 3. Yeah, 15 is 3 times 5. 6 is 2 times 3. The only thing that's in common is the 3. So the greatest common factor is just a 3. If there were more of them, we'd multiply them together to get the greatest common factor. So 3 is the biggest number that divides evenly into both of them. Then for the variable, it's the smaller power for factors. If it were multiples, it would be the larger power. We're looking at factors, so it's the smaller power, which is the x squared. Now up here, when we factored this 6, when we said 2 goes into 6, how did we get the 3? Yeah, 6 divided by 2 is 3. So same here. Once we say that 3x squared is a common factor, how do we get what's left over? Well, we divide this by 3x squared. So 15, when we divide by a single digit, we divide each digit separately. So 15x to the third divided by 3x squared. Well, 15 divided by 3 is 5. X to the third divided by x squared, just x. 6x squared divided by 3x squared. Well, 6 divided by 3, positive 2. And x squared divided by x squared cancels out. Notice we got back to what we started. That is always the first thing we look for when we are asked to factor, is greatest common factor. So let's take a look at other examples of this. Come on now. So we have 24x to the fifth y plus 36x to the third y to the third. So we're going to look at that 24x to the fifth y, 36x to the third y to the third. What is the greatest common factor of those two? 6 will go into both of them. There's a bigger one. Careful. 12. If we factor the 24, it's 2 times 2 times 2 times 3. Factor the 36, it's 2 times 2 times 3 times 3. We have a 2 in each, another 2 in each, and a 3. 2 times 2 times 3 is 12. And if you have to factor, please feel free to do that. Now, remember, it's the smaller power. So for x, it'll be x to the third. And for y, just y. Y to the 1 or just y. So that's our greatest common factor. So that is one of the factors we're going to take out. To figure out what the other factor is, we have to divide this by 12x to the third y. 24 divided by 12. 2. X to the fifth divided by x to the third. X2, exactly. 5 minus 3 is 2. Y divided by y cancels out. 36, x to the third, y to the third. Divided by the 12x to the third y. 36 divided by 12. Positive 3. X to the third divided by x to the third. Cancels out. Y to the third divided by y. Y squared. We think of that as y to the 1. 3 minus 1 is 2. So that's it. We can have bigger than 2 digits. We might have something like this. We'll throw in a negative in here just for fun. So something like this. Now we've got 3 numbers. Let's just look at the numbers. 20, 35, 25, and 40. What is the largest number that divides into each of those? 5 is the largest number. And if you're not sure, you can divide them out. What's 35 divided by 5? 7. 25 divided by 5? 5. 40 divided by 5? 8. Do those have anything that they can all be divided by? Well, the 7, 5, and 8 don't have anything else they can be divided by. So that's as far as we can go. If we divided out the 5 and there was still something like a 2 or a 3, well, we'd have to divide that out and combine it with the 5. But we know we're good here. Now for the variables, for x, what's the smallest power of x? We've got x squared, you've got x to the 1, and there's no x here, which means no x. Yeah, no x is the lowest power. So there is no x in our greatest common factor. How about for y? We've got y, y to the third, y to the fifth. Just the y. So 5y is our greatest common factor. To figure out the rest of it, we divide by 5y. Excuse me. 35 divided by 5 is 7. X squared divided by nothing. X squared, and y divided by y cancels out. Perfect. Negative 25 xy to the third divided by 5y. Well, negative 25 divided by 5, negative 5. X divided by nothing, just x. Y to the third divided by y. Y squared. Good. 40y to the fifth divided by 5y. 40 divided by 5, positive 8. Y to the fifth divided by y, y to the 4. That's it. Next, I want to go back up to this second example right here. When we did that, I was careful to map out this. This first digit here, we said comes from right here, just combining the first 2 digits of our other numbers. So we look at this, of course, our first step is to always look for greatest common factor, and there is none. This is a 1x squared, so there's no number in there, and then there's no x in this one, so there's no variable. So there is no greatest common factor. So when we do that, we look at doing, it's called reverse multiplication. We're going to abbreviate it as multiplic, or sometimes called FOIL in reverse. And all it means is we're looking at this and we're saying, okay, this has 3 digits in it. There's 3 digits in that. We're assuming it's going to follow our pattern. It's going to break down into two-digit numbers that multiply together. To figure out what those are, well, this first digit here is made by combining the first 2 digits of those numbers. Well, the only way to make x squared is x times x. So we know that has to be x times x. Now we jump to this last digit, the 21. We know that digit comes from combining the last digits of the other 2 numbers, from these 2. So that means these 2 have to multiply to make 21. That leaves us with only 2 options. 3 times 7 or 1 times 21. Only combinations. Let's try the 3 times 7. Now, right now, we multiplied these together, so we had this up here. We know that's right. But if we didn't have that to look back at, how would we know if that 3 and 7 is correct, or if we should have used the 1 and 21? Well, we double check. We know this middle number here comes from combining the outside and the inside. So let's check the outside and inside down here. On the outside, we have x times 7. That's 7x. On the inside, we have 3 times x, which is 3x. What does that add up to? 10x, which is exactly what we wanted it to be. So that factors to be x plus 3 times x plus 7. So here again, we check, are there any common factors? No, the first one has a number of 1, so there's no factors of 1. And there's no variable in the last digit, so there's no variables that are factors. So if there's no common factor, no greatest common factor, we go to do that reverse multiplication, where we know it's going to be 2 two-digit numbers. We know that this digit is found by multiplying this one and this one, which means those 2 digits have to be x and x. Yes. We know the 10 comes from multiplying this one and this one. So that's either going to be 2 times 5 or 1 times 10. Which one do you want to try? 2 and 5. So positive 2, positive 5. Oops, I wrote 5 twice. 2 back there. Now there is another alternative. It could have been a negative 2 times a negative 5 would make a positive 10. We'll look at that option in a little while. To see if that's the right option, let's double check. X times 5 is 5x. On the inside, 2 times x, 2x, which adds up to 7x, which is what we want. So that's it. X plus 2 times x plus 5 is the factoring of that. Yeah, that'd have to be a negative 7. Yeah. So here, no common factors. So we go to this reverse multiplication. The first digits have to multiply to make x squared, so that's going to be x and x again. Last digits have to multiply to make 12, so that's going to be 3, 4, 2, 6, or 1 and 12. You want to try the 2 and the 6? Let's try the 2 and the 6. On the outside, x times 6 is 6x. On the inside, 2 times x is 2x. Adds up to 8x. Is that what we want? No. So that tells us there's an issue there. 2 and the 6 don't cut it. Yeah, you've done it in your head. The 3 and the 4 don't work either, so we're going to try the 1 and the 12. Let's double check it. On the outside, x times 12, 12x. On the inside, 1 times x, 1x, which adds up to 13x. That is what we want. So there's our factoring. X squared plus 13x plus 12 is equal to x plus 1 times x plus 12. So here, no common factors. So we go to that reverse multiplication. Of course, x squared has to be x times x. 36 can be 4 times 9, 6 times 6, 3 times 12, 2 times 18. Now, you had mentioned earlier, they're either both positive or both negative. Since this is minus, that means both going to be negative. Yes, we know that. Which one do you want to try? Okay, you're starting to see a pattern there. We try the 2 and the 18. We double check. X times negative 18 is negative 18x. Negative 2 times x is negative 2x, which adds to negative 20x, which is what we want. You're starting to see that pattern that these two have to multiply to make the 36 and add to make the negative 20. So time for me to do something about that. So here, no common factors. These two, the first two have to multiply to make 2x squared. So one of them has to be 2x and the other one x. The other ones have to multiply to make 6. So that's either 2 times 3 or 1 times 6. Now you might be looking at that thinking, well, the 1 times 6 looks like a winner because that adds to 7. There's a problem. This is 2x. If I try 1 and 6 in there, on the outside I have 2x times 6 is 12x. On the inside, 1 times x is 1x. That's 13x. Not what we want. Now, because this is a 2x up here, we could switch them. I put the 6 here and the 1 there. If I try that, 2x times 1 is 2x. 6 times x is 6x. That's 8x. That's still not what we want. Which means 1 and the 6 are not it. So we're back to the 2 and the 3. So let's do 2 and 3. On the outside, 2x times 3, 6x. Inside, 2 times x, 2x, that equals 8x. That's not what we want. Does that mean the 2 and the 3 don't work? No, it means we have to switch their order. Try the 3 here and the 2 there. Now we've got 2x times 2 is 4x. On the inside, 3 times x is 3x. Adds up to the 7x, what we were looking for. So 2x squared plus 7x plus 2 factors to 2x plus 3 times x plus 2. So it gets to be a lot of fun there. The real fun starts when we hit something like this. Now, again, there is no common factor. So we're going to do the reverse multiplication. Now, this is back to just x squared, so we know these first two are x times x. But this is a negative 28, which means one has to be positive and one negative. So that could be 4 times negative 7 or negative 4 times 7. Could be 2 times negative 14 or negative 2 times 14. Or negative 1 times 28 or 1 times negative 28. Which one do we want to try? Okay, let's do a positive 4, negative 7. So x times negative 7, negative 7x, and 4 times x, 4x. That adds up to negative 3x. That is what we want. So since we're having fun with these, let's do 8x to the 5th minus, oh, what do I want to do here? (190x to the 4th) minus 48x to the 3rd. Now, the first thing we will notice here is there is a greatest common factor. Two ways we notice that. The first one, the easy one to notice, there's an x in every digit, isn't there? If that variable appears in every digit, it's a common factor. So there's going to be a greatest common factor. Also, all those numbers are even, aren't they? So we know you can at least take out a 2. So it's going to be a 2, and what's the lowest power of x? X to the 3rd. So let's divide out that 2x to the 3rd and see what's left. 8 divided by 2 is 4. X to the 5th divided by x to the 3rd? X squared. Good. Negative 190 divided by 2? Negative 95. X to the 4th divided by x to the 3rd is just x. Negative 48 divided by 2 is a negative 24. X to the 3rd divided by x to the 3rd goes away. Now remember when we were factoring before, if we had 8, when we did 18, we might have had like 2 times 9. The 2 is prime, but we could keep splitting up the 9. Same here. That 2x to the 3rd is still there. But let's see if we can split this other piece up further. We know these two multiply to make the 4x squared, don't we? So we might try 2x and 2x. Well, 24, that could be negative, well, 4 times 6, negative 4 times 6, or 4 times negative 6. Or 3 times 8, one of them negative. 2 times 12, one of them being negative. 1 times 24, even with one of them being negative. We're running short of time, so I'm going to tell you, we could try all those. They ain't going to work. It's going to be 4x times x. This is going to be negative 1, positive 24. On the outside, 4x times 24 is 96x. Negative 1 times x is negative 1x, which is, oops, I did that wrong. It should be a positive 1 and a negative 24. This is negative 96 and positive 1 gives us the negative 95. That's one I like to give students to do because they'll sit there with the 2x and the 2x and they'll keep going. They'll try a possibility. And even once they switch to 4x and x, they want to use the 4 times 6 or the 3 times 8. Takes them for, this is usually the last possibility they try. So that problem might pop up again someday. Well, there is a new quiz. which is due tomorrow, Thursday, by 11:59 p.m. And new homework due for Monday, class time. What's that? Or sorry, next week. It's a week from Monday. You're right. March, what is that? The 26th or something like that. Yeah. Monday, March 26th at class time. Tomorrow we'll do a little bit more of this factoring, and then we'll do some stuff to set us up for after spring break. Okay. So you get that out of there before I say this one.